Imagine spending decades trying to stop something from happening, only to discover it might actually be the answer. That's exactly what's happening with one of the newest rocket engine designs. For generations, engineers treated detonation as the enemy. Inside traditional rocket engines, fuel burns in a controlled process called combustion. It's steady, predictable, and that's exactly what engineers want. A detonation, on the other hand, is violent. It's a shockwave moving faster than the speed of sound. Normally, that's bad news. But researchers started asking a simple question. What if you could control that explosion instead of preventing it? The result is something called a rotating detonation engine, or RDE. Instead of burning fuel continuously like a normal engine, an RDE creates one or more detonation waves that race around a circular chamber thousands of times every second. Those shock waves constantly compress fresh fuel and air before igniting it again. The process repeats over and over without stopping. It almost sounds impossible. Yet engineers have already built and tested working prototypes. Why go through all this trouble? Because detonation is incredibly efficient. By extracting more energy from the same amount of fuel, future engines could produce greater performance while reducing weight and complexity. For rockets, that could mean carrying heavier payloads into space. For high-speed aircraft, it could improve range and efficiency. Some researchers even believe rotating detonation engines could play a role in future hypersonic flight. Of course, making controlled detonations happen thousands of times every second isn't easy. Temperatures become extreme. Pressures constantly change. The engine materials must survive conditions that push modern engineering to its limits. Sensors, cooling systems, fuel delivery. Every component has to work perfectly. One tiny instability, and the detonation can collapse. That's why researchers around the world continue testing new designs and materials. While the technology isn't ready to replace every rocket engine today, the progress has been remarkable. And honestly, it's one of those breakthroughs that completely changes your perspective. Sometimes, the biggest engineering advance doesn't come from avoiding danger. It comes from learning how to control it. Because the future of rocket engines might not burn fuel quietly. It might explode on purpose